Hello, webinar attendees. We're very happy to have you with us today. Thank you for joining us. We've got quite a number of participants with us for today's webinar. Let's get right into it. My name is Troy Bankhead. I'm the Director of European Operations. I am American, but I have been living over in Europe for a good number of years, and I opened the European office for TechSite. I'm also the company's VP of marketing, but more pertinently, I was the former product manager for our bacteriology algorithm, and in specific, the BV algorithm that was developed actually over here in collaboration with one of our lab partners in Luxembourg. In today's webinar, I'd like to go over just a bit about who TechSite is, but mainly why it's interesting today to go digital for bacteriology gram reads. Now, just a bit of housekeeping. We do welcome questions, and if you have any, feel free to send them over to your chat channel, and our collaborators will be able to receive them and feed them to me. And we will have a Q&A session at the end. But if I see a question during the presentation, we might just stop and answer it. So without further ado, let's talk a bit about TechSite. We are a software company that's specialized in developing AI-powered solutions for the medical industry. I say the medical industry, but we do have three verticals. The first being environmental, where we use our same technology, the same image analysis frameworks, to serve the home inspector market for mold testing, because the way that they test is done on microscopes today. The second vertical that we service is the veterinarian field, and I will talk about that in just a moment. Don't want to give too much away just now, but our third and main vertical is the human. And in that area is where we have placed most of our efforts, and of course the core of our development is happening. We were founded in 2013, and since then we've grown to over 120 people. We've got good profitability, and we, as I mentioned earlier, have two offices, one in Orem, Utah, and the other one in Luxembourg. Although we are a remote first company, which means that our employees are located pretty much everywhere on several continents. I mentioned one of our verticals, veterinarian, earlier, and the reason I mention it is because we licensed our software to one of the largest brands in pharma diagnostics and labs for the veterinarian market, which is Zoetics. This was an important event for us because as they branded us as VetScan Imagist and took us out to the world, it enabled us to prove not just the models, the AI models, but also our platform. Indeed, with one scanner located in the veterinarian's office, he could then do ova and parasite detection for companion animals plus equine, digital cytology, AI for dermatology, urinalysis, and we continue to work on more tests that can all be run within the veterinarian clinic on this, no back and forth times to get lab results. It all happens in 10 minutes. And we've sold thousands of scanners worldwide and have serviced over 3 million patients. And so that has enabled us to really prove the scalability of the platform as well as the viability of the tool itself. Now, there's another important announcement that we made earlier this year, and that's our collaboration with Mayo Clinic. Mayo Clinic, after quite some time of due diligence and validating various solutions, chose TechSite to be their preferred clinical pathology AI platform. And what this means is that they have invested in TechSite, offering their services, expertise, and their network to help us create new AI algorithms, workflows, and basically further our list of indications that we are able to service. And they will use it both internally, but we will also bring it to the world. TechSite as a company is known for AI, but it's important to realize that the AI is just one component. As you can see on the screen, yes, data curation and AI algorithms is central to what we do, but it's just one component between the fact that our platform is a very capable image management system. We also need to develop custom workflows that are very pragmatic and work for the lab technologists to make their work go quicker and more efficiently. We've also had to become experts on image acquisition, security, scalability. We need to integrate with the LIS systems, and so we've developed an open API. And of course, compliance and regulation is forefront in our concerns. We have a department that does nothing but that. And so it's much more than just AI. And as a company, our mission is to be the world-leading digital diagnostics platform for clinical pathology and infectious diseases. But you didn't come here to hear about TechSite. You came here to hear about the 5 reasons to take your gram stains digital. And gram staining is a cornerstone of bacteriological analysis. It aids in the differentiation of the major bacterial groups. It's the critical first step in the identification and the antibiotic susceptibility testing of bacterial organisms. And reason 1 to go digital is workflow organization. Now, workflow organization has a direct impact on lab efficiencies, and it can make the difference between a negative contribution test and a positive contribution test. In the world, by 2050, it's estimated that the population above 60 years old will be 22%. The fact that the population is growing means that more lab tests are going to be needed, and that requires workflows within the labs to be studied more carefully. There was 1.69 billion bacteriology tests performed worldwide just in the first world countries. And so that introduces as well, increasing competition for service, price, quality, accuracy. And that in turn puts pressure on the labs to look at each test's profitability or in the case of where it might be losing the lab money. And while technological advancements in culture reading, bacteriological identification, antibiotic susceptibility testing have improved the process, the gram stain today remains a manual process based on the microscope, which, as you know, is a 400-year-old technology. And so the process today is that the laboratory, the technicians will start the culture workup, which takes anywhere between 1 and 2 days. And the culture is good for identifying the live bacteria in a sample. Well, the gram stain, before the cultures are read, needs to also be made. And this is where often there's a bottleneck in the laboratory, because it takes around 2 minutes of direct exam on an average, and it confirms the presence or absence of positive and negative gram bacteria and provides morphological and other information about the bacteria. What happens next is you've got collaborator review, which basically in most laboratories, they've got policies that require them to have a secondary consultation upon positive cases or even certain negative results. And then once that happens, all of those slides need to be stored short term in case there are discrepancies in the cultures that need to be discussed. Now, this has a direct impact on the timing because the gram stain takes a lot of time, in addition to the fact that acute infections need quick response. But you also get inter and intra-operator variabilities, which are just due to the human condition, and manual read times, just they cost the lab money. Now, in a digital process, it's somewhat different. You create your slides, either by smear or cytospinning. You then scan those slides, and those the list of scanners we can, of course, consult with laboratories on which would be the most appropriate. Those images, once they're scanned, are automatically uploaded to TechSite's systems, where we automatically select fields of view. We offer a 10x and 100x review of those fields of view. We also, for BV today, have the AI analysis, of course, and all of the other sample types for bacteriology are coming early next year. And you can, of course, request collaborator review, all via our interface. Now, when the reviewer is done saving their notes in the interface, they can either generate the PDF report or they can export any of that data to their LAS system. And so already with the new digital process, the workflow can be not only customized, but streamlined. And another great advantage to digital is that the simultaneous consultation of the culture and the gram leads to significant time savings when you can bring the gram stain real time while working on your culture workup. Having that image pulled up while you're working on the culture allows for easier correlation of the results between the two. Another point in workflow that's important is staffing, and one of the challenges that any lab faces is in education and ongoing certification. And with the digital workflow, you can incorporate features such as pressing the E key in our interface brings up a list of expected images for any of the classes that you're identifying. In this case, we're showing some Gardnerella, which can help either certify or train new people coming into your lab's workforce. And so workflow optimization is key, one of the key factors that should be pushing us to go digital, because aside from all the obvious benefits of less paperwork, less retranscription and results, it also leads to benefit number 2, which is slide storage and retrieval. Now, in a normal lab setup, if you need to locate a slide, you often have to dig through unorganized slide boxes. This process is pretty time consuming. And in fact, the image that you see here would probably represent a very well-organized laboratory. For example, the labs that we visited often just have their slide trays stacked up in a corner. And when they need to get slides, they have to fish through them, locate them, bring them back to the microscope so that they can use them. Well, situations also arise where slides are tossed before you're aware of a discrepancy on the culture and you're no longer able to review the slide. Whereas in a digital environment, you have instant retrieval for secondary or future reading needs, and those results can be viewed immediately right next to the culture results. It's easy to mark rare bacteria or areas of interest for review, which has a huge time savings for the secondary read process as well, meaning the chef or the head bacteriologist will no longer have to interrupt a tech to have them look over their shoulder when you find a difficult to locate organism on a slide, for example. It also provides a permanent record of your gram stains, not just for audit purposes, but it eliminates the need for physical slide storage. And so all of that footprint and disorganization in your lab just disappears. And then lastly, your slides are always available, either using the built-in PDF reporting or the open API that allows you to take any information, including images from our system, and put it back into your lab's reports. You always have them available. And that also enables remote consultation and education, because even in education, many people have a camera hooked up to one of their microscopes. But taking those pictures is time consuming, and the results usually aren't as clear as the digital images. Reason 3, improved analysis. This is where I'd actually like to dive in a bit. Because of all of the improvements in the lab, this is the one that can have the potential biggest benefit. There have been, over the recent years, major technological advances that improve clinical lab diagnostics for monitoring, further enhancing patient care, and all of these innovations have added recognizable value to lab medicine and in the healthcare sector. One of these is artificial intelligence. In particular, we as a company work with deep machine learning. And without geeking out too much, deep machine learning is basically a method in artificial intelligence that teaches computers to process data in a way that's inspired by the human brain. It's called convolutional neural networks. And it uses interconnected nodes or neurons in a layered structure that resembles the human brain. And it creates an adaptive system that computers use to learn from their mistakes and improve on continuously. And so these artificial neural networks They attempt to solve complicated problems like summarizing documents or recognizing cars, road signs, or in our case, cells and microscopic organisms with greater accuracy and consistency than humans are capable. And I say that because, as a general rule, computers are always going to be better at accuracy and consistency. Humans get tired, distracted, and it just takes us more time to review an entire slide. They can do that exponentially quicker and more reliably than humans. However, humans remain today better at critical thinking, meaning we're able to make those non-obvious visual and associations between the data that we're viewing than computers are able to. And the result is that humans plus computers give us a better result in less time. Now, this applies directly to bacteriology and the Gram stain because our software has two different versions today. Our first collaboration with Mayo Clinic resulted in a bacteriology tool for all of the sample types that you see on your screen today. And it doesn't yet include the AI. I'm going to talk about that in just a moment. But what it does do is it is a precursor to our full solution that introduces bespoke workflow for the bacteriology testing and enables Mayo Clinic to have decentralized sample collection, centralized reading, and to dramatically improve their workflows. And we do this by an interface that includes three main elements. On the left-hand side, you've got the sidebar that shows everything that's going to be included in your final report, all the organisms that the AI is able to detect, or in this case, that the human can analyze, along with an image viewer that shows fields of view. It also shows objects, and we also have a zoomer that allows you to play around with the image as you deem necessary. And what this does is it enables the users to rapidly correlate the results of a culture with the Gram stain. The second version of this that I would like to cover with you is our bacteriology gram analysis. And this is the actual version of the tool that was developed over here. And this is one of the high volume tests in the laboratory that, yes, since COVID has seen quite a bit of change in the fact that a lot of companies now, or a lot of the labs now have PCR machines, and they're looking for ways to make money with them or to use them. But our bacteriology gram analysis still has a very solid place in the market for several reasons. First of all, it allows for rapid screening of BV tests. It allows the users to detect not just the BV components, but some other organisms, as you can see on the screen as well. And more importantly, we have just completed 2 studies. And on our first validation study, we had between 96% and 100% sensitivity, which means that compared to the gold standard viewing, we were spot on. Now, the story that I like to tell here is in the specificity. Those numbers are lower because our software plus a technician or a technologist detected more BV than the manual gold standard. And so that's where those discrepancies came in. In our timing study, the laboratory that we led the study with, on an average, they found a 107-second read time, whereas their technicians with our software brought that down to 26 seconds, which is over a 3/4 reduction in read time. I mentioned PCRs earlier, and we added an endpoint to our clinical trial, which was the PCR direct view versus AI plus technologist. And we attempted to use it in the study. However, we in the end weren't able to because the assay that we used only included a very limited amount of bacteria. But more importantly, 70 of the 240 slides were marked as inconclusive from the machine. And when we were talking with them, they said, yeah, apparently that's something that just happened. So unfortunately, the silver bullet of PCR didn't turn out to be as such. But I want to concentrate on the time savings as opposed to the accuracy. We have 100% accuracy compared to the the gold standard, which is the manual read, yet we introduce a time savings of 76%. Now that has several direct impacts in the laboratory, not the least being turning a negative contribution test into a positive one because of the time and labor savings without compromising on quality. Going on to reason 4, working conditions. Now, everyone knows that basically microscopy is difficult. From our experience, because this is all we do, whether it be in fecal parasitology, hematology, our cervical cytology solutions, bladder cancer, all of these areas require the technicians to be hunched over the microscope all day long. And it's hard, it's slow. We have reports from our partner Mayo Clinic of repetitive wrist injuries resulting from continual manipulation of the microscopes. This software removes all of that. It just works. You get rid of the complications due to the microscope, and the migraines that are reported when people use the microscopes disappear, and it becomes a more attractive work environment. Which leads me to reason number 5, being recruitment and retention. There is a universal, worldwide common challenge that laboratories face, and that is, on the one hand, the loss of expertise and experience upon retirement when they have their senior staff that leaves the lab, and the new generation of incoming talent prefers flexibility, they prefer digital, and that makes a very difficult proposal when trying to hire people to work in your laboratory. These challenges are solved with digital, because with digital, you remove the barrier of the microscope. The incoming people are working with AI in an environment that is much more flexible and gives them the comfort of being able to work from monitors, even have remote consultations, and be able to offer candidates a much more attractive package when hiring for microbiology departments. So of those 5 reasons, the resume for the Gram Stain digitalization is that it allows you to rapidly correlate your cultures with your grams. It removes the bottleneck that is traditionally the Gram stain, which takes the most time. It allows you to quickly screen through the negative slides, which is important for the technicians, because as you remove the part of their job that they're used to, which is spending all their time looking for stuff, you give them more time to concentrate on analyzing the cases, especially the abnormal or interesting ones. You remove, or you at least reduce, the inter and intra-operator abnormalities or inconsistencies, and you increase the per test contribution margin. You also remove the entire need for physical slide storage in your laboratory, as digital can completely replace it. And it gives you a permanent record, both for compliance auditing, but as well for future retrieval. And last but not least, it's a better working environment for techs. It allows them to work remote, and it's removing a lot of the challenges that they faced with the microscope. So there's the 5 reasons for moving your Gram stains over to the digital environment. I'd like to move now to a Q&A session and invite anyone who might have a question to go ahead and ask that right now. So we've got a first question that is the AI continually learning and changing, or does the algorithm stay the same? It's actually a great question. Because of the short answer is yes, it is. And the AI, with every input, with every use, does enable us to revise the model. But because we are in the medical realm, and because, I'll speak bluntly with you, the FDA, we have a great relationship with them, and they are good to work with. but their methods for certifying in vitro medical devices doesn't really work with the concept of something changing all the time. And so we have to work with them and freeze our algorithms at releases. And so as we come out with new releases, we have to get those reapproved. And so the process today remains laborious and certainly not optimal for AI. And we're confident in the years to come that they will adapt their certification procedures to enable more of this continual improvement to happen. But today, because we are committed to the existing regulatory frameworks, we work within their rules. And so what we do is we come out with a model, we release that model, and then in the future, as we get updates, we will also revalidate them with CE and FDA. Katie asked if we can see a demo of the platform, and we would absolutely love to show you the platform. It's something that we do all the time, and of course with video conferencing, that's very easy to do. My recommendation, Katie, would be to reach out to Jenna, who can set an appointment, and we love to walk you through all the details of the platform and how it works. I've got a question: how much is the scanner, and what is the charge per slide? Another great question. Boy, I wish that there was an answer that I could give you that is the scanner, like if there was one. Today's scanner market, there is no silver bullet scanner that will do everything for everyone. If you've got a high volume lab, we're going to recommend the Hamamatsu S360, or if you're a low volume lab, maybe a Promana or even a Grundium. There are many slide manufacturers on the market today that do a good job and that we can recommend to you, but there are some other discussions, such as the resolution of the scanner, the other needs, because keep in mind, with our software, you can have one scanner and perform several tests in the microbiology department. And so we need to look at those considerations as well. And then in terms of the charge per slide, we don't have licenses or users. You can have as many of those as you want. It's simple pay-per-use. So our business model is very simplistic, and we basically just sell scan packs. And so you pay as you use. And those costs, again, Jenna can go over that with you to discuss what those costs are. And you'll find that they're very, they work with either the local nomenclature reimbursements for Social Security, or private labs are usually able to find the profitability in their charging schemes. Steve asked, can you show some case examples? I'd love to, but in the time that we have, we've committed to doing short and sweet webinars, to keep it very short. I was able to show you a few screenshots, but your best bet there is going to be to reach out to Jenna and just schedule a quick demo. There's of course no obligation. We'd love to just show you through it, but there we can go through several cases, both of BV, but also of other sample types, whether it be expectoration, ear, eye, nose, throat, all the, to be able to show you what they look like concretely in some real world examples. And yes, Kay, this is an LDT. It's a lab developed test. Although in Europe we are CE marked, we in the US are not yet done with FDA, but those are underway. We've got a whole line of FDA approvals that we're working on today. Esther asked, would the AI identify an unusual morphology or something that was not trained to recognize? No. Short answer is no. The AI is able to recognize the objects that it's been trained to recognize. Even AI isn't a silver bullet. There is a version of AI called unsupervised learning, where you simply feed it data and it spits stuff out. But we obviously don't do that because we need to control and we need to feed it what we want on the output. And so we teach the algorithm by giving it hundreds of thousands of examples of what we want it to learn. It then learns it, and we are then able to do that on samples of things it's never seen before. But in terms of unusual morphologies and things, what our software is good at is if it has been trained, for example, on yeast or filamentous mycelium or hyphae or epithelial cells or anything, and it does detect anomalies but still groups them, it will present them. We had a question from Jeff. Can the AI assess specimen and gram stain adequacy, such as over and under decolorization? In our interface, A part of the interface does allow for the operator to say whether the specimen is adequate or not. In fact, in cervical cytology for the pap smear, that's even one of the Bethesda requirements to specify that. So that the interface does, but it's visual from the operator. Once again, we're not doing the operator's job for them. We're just making it very quick and a lot more efficient to determine whether it's over or under decolorized, because we show them the fields of view and they're able to very quickly screen and make those determinations, tag the slide for rescanning if it needs to, or whatever needs to happen in the workflow after that. Tiffany asked, do you work with educators for laboratory programs? We work with university hospitals and medical school hospitals. Purely for education, we don't, although we do have an education module. And as I showed, our tool does include some pretty nice features that help laboratories and or educators use our system, the images, and even the interface to help educate. So that would be something I would encourage you to maybe reach out to Jenna and just have her talk to you about education and how we can help there. And Jonathan asked, what are the challenges with obtaining high quality scans for these types of specimens in order for your algorithms to have the optimal output? Are there scans where the algorithms have more difficulty and require a rescan? Great question. Synovial fluid, some of the sterile samples on the body, unlike vaginal or wound where you're pretty much gonna find stuff. They're a challenge because in these sterile environments, it's a challenge to tell the scanner where to focus. And so we've actually developed custom cover slips that all scanners require cover slips. But we've developed these cover slips that have printed fiducials on them that we use to tell the scanner how far below it we want it to scan. And with that, we've got excellent results, and we're even validating with Mayo Clinic the smears and things like, even synovial fluid and aspirates in order to read those sterile environments and be able to focus on them. But yes, it is definitely a challenge for the scanners, and it's one of the areas that we've had to get good at in working with image acquisition. And yes, there are some scans that need rescanning or some slides. And for that, our system allows to check a box, and that then sends the scan back to an inbox where your lab techs can see what cases need to be rescanned. And so we've worked that into our efficient workflows. Patricia asks, does it recognize yeast forms of blastomyces? Now, currently the yeasts that we're able to detect are in AI, they're in our vaginal, the BV detector. So it does detect the yeasts, but in our other sample types, yes, we do detect the yeasts. But today, keep in mind that our other sample types, it's probably going to be towards January that we're going to start rolling out the AI for all the other sample types. And so things like the blastomyces can come from that. But yes, the algorithm does detect yeasts. There are some class confusions at times, but if you are interested in a demo, the class confusion and false positives and other interesting topics like that are actually really good for the demos, because we can show you how the software is optimized not to miss anything, but still leave the control in the hands of the bacteriologist or the technologist to be able to quickly scan and say, yes, that's a yeast, or no, that's a cluster of gram-positive bacilli, or it's a big nuclei, whatever it might be. And so the interface is designed around having a professional lab technician using it. And so we always like to give them more visibility into the sample than just the true positives. And so with that in mind, I think we have answered all the questions. I would like to extend a very warm thank you to all of our attendees today. We love reaching out to our community and spreading the word about our technology. And if you have any interest in demos or any further discussions, please feel free to reach out to Jenna, who you might already have contact with, and we would be happy to organize a demo for you. And lastly, we will be emailing you a link to this presentation so you can have all the notes and everything that we presented today. So with that being said, I wish you all a great rest of your day, and TechSite will now sign off.